It's time for our math lesson today, and we are coming down to the end of our chapter on geometry. So today we're going to review all the different things that we talked about in this chapter, and tomorrow you're going to have a test. So let's get started. Chapter 15 review. We started out the chapter talking about angles. Remember, a ray is a line that goes on forever in one direction but stops at an endpoint. And angles are made up of two rays that share a common endpoint. Here's a couple examples of angles, and you can see the two rays that come together and they meet at a point. We call that point the vertex. Now, when you get into upper grades, you'll learn how to measure that angle. But there is one angle that we learned how to measure in this chapter, and that is a right angle. The angle on the left, the two rays meet and form what we call a right angle. That would be 90 degrees. And I told you, you have your little card or little piece of paper that you hold up there, and you can see that the rays that form that angle follow exactly along the sides of your piece of paper. If that happens, you have a right angle, and the correct way to mark it is with that little square in the corner. And you'll have to do that on your page for today and on your test as well. We also learned about shapes that were similar. In this situation, we have a hexagon, 6 sides, 6 angles, 6 vertices. And they are exactly the same shape, but the left one is larger than the one on the right. So we say that these shapes are similar. Any two shapes that are exactly the same shape are similar. If you want two shapes to be congruent, they not only have to be the same shape, but they have to be exactly the same size, meaning that you could stack them on top of each other and they would exactly fit. So these two purple triangles are congruent. Remember, triangles have 3 sides, 3 vertices, and 3 angles. Even if I turn one of those triangles, we can still say that the triangles are congruent because they are still the same shape and the same size. We also learned about slides and flips and turns, and we used a book on the table as our example. Let's see what's going to happen to this math book. Basically, nothing happened except it slid across the table or across the screen in your case. So we call that a slide. Anytime a shape does not change its orientation, it just is moved to a different spot, we say that is a slide. Let's see what happens to this math book. Oh, it doesn't look the same, does it? It must have been flipped. That's right. So the book was right side up, and now it's been flipped over, and we cannot see the front cover anymore. We call that a flip. And one more. I wonder what's going to happen to this math book. Oh, so it just turns. We call that a turn. So slides and flips and turns. All right. We also talked about the word symmetrical. And shapes can be symmetrical. And what that means simply is that you could fold it in half and both sides would be exactly the same. Here's another hexagon, 6 sides. And you can see the dotted line down the center. This hexagon is symmetrical because if we could fold it in half, it would be exactly the same on both sides. Are there other ways that you could mark the line of symmetry on this hexagon? Sure. There are several ways in which you could do that. You could draw the line from one vertice to the opposite vertice, and that would work as well. We also learned about some solid shapes. So let's review them real quickly. Do you remember what this solid shape is called? It's a cylinder, that's right. And some examples of cylinders that you might have in your house. Cans, that would be the simplest one. In your mom's cupboard, cans of vegetables or fruit, soup. Maybe glasses in your cupboard are cylinder shaped. Let's try another one. Do you remember what that one's called? Okay, it's called a cube. And it has 6 faces, and each face is a square, so we call it a cube. And you probably have some cubes around your houses, maybe some boxes that you have. Maybe you have a Rubik's Cube. I know you had some in the classroom. Someone brought one in. So that's a cube. What about this shape? Remember we name these solid figures by their base. And the base of this is a rectangle. So we call it a rectangular pyramid. And that's an interesting shape. I think I have some tea bags at my house that are shaped sort of like that. I don't know. You may have a prism or something at your house that's shaped sort of like that. How about this one? If you said cone, you were correct. We have some cones here that we like to use on break time. And you might say the tip of your pencil is cone shaped. And you might find some other examples of cones around your house. Let's look at one more. How about this one? What's it called? Yes, it is a rectangular prism. What's the difference between a rectangular prism and a cube? Okay, so a cube is special because every face is a square. In a rectangular prism, every face is a rectangle, and they don't necessarily all have to be the same. In this one, you can see that the end shape is a square. However, the side and the base, top, are all rectangular. So we call it a rectangular prism. All right, well, you have some activities to do on your page today. Work through them carefully. If you're not sure about any of them and you're kind of nervous about the test, give me a call and I can give you some help. We can get it all worked out before you have to take the test tomorrow. Have a great day.